Now, good afternoon and welcome to another edition of our class on the MAT 221 titled Real Analysis 2. In the first class, I give you the synopsis of this course, and I said we are looking at three major topics. The three major topics are series, improper integral, and the Riemann integral. Riemann integral. However, each of these topics is a bit broad. So we're going to look at series. What is series? What does it entail? That will be the focus from now. So we're going to look at improper integral as soon as we complete the series, and we'll also look at Riemann integral. Once again, you are welcome. Now, in real analysis 1, we talk about sequence of real numbers, and we focus on convergence of sequence. When do we say that a sequence converge? So that was the major focus. We look at so many conditions. We look at criteria for convergence. That is where we talk about null sequence. That any sequence that is null is automatically a convergent sequence. We look at what effect does boundedness has on convergence. All these were discussed in real analysis 1. We want to extend our study on sequence to series, because there can never be series without sequence. And major concern that we're going to look at also will still be convergence. Convergence. When do we say that a series converge? At what point do we say that? What are the criteria? The criteria for convergence of series. What are those things that we need to know as far as series is concerned? Then also, we also need to look at if a sequence converge, does it mean that the series of that sequence will also converge? These and more are the questions we need to provide answer to. Once again, you are welcome to Real Analysis 2 class. So what is a series? Literally, series is the sum of the terms of sequence. Sum of the terms of a sequence. That is the literal meaning of series. It's called series. Full stop. Now, that is simple definition. Now let me be a bit mathematical. Suppose A1, A2, A3, up to AN, and it continues, are terms of a sequence, comma, the sum A1 plus A2 plus A3 plus AN plus is called the series. Full stop. It's called the series. Now, you need to remark that A1 plus A2 plus A3 up to AN plus can be written as summation AN n from 1 to infinity. That's remark 1. That's remark 1. Remark 2. Remark 2 is summation n from 1 to infinity is infinite series. Problem figure 3, summation. Let me change this one to I. Let me use I from here. Up to n, let me use I. AI. I from 1 to I from 1 to n is finite series. Now, look at this. This second one, summation, I from 1 to n, simply means I have A1 plus A2 plus A3 plus up to AN. It stops at this point. It does not continue. Why this one? The moment you get to AN, it continues. And that's why it is called infinite. Our major focus for this course will be on infinite series, basically. Because if you go back to the sequence, when we're discussing convergence of sequence, we're also looking at the behavior of the sequence as our n, the n is getting arbitrarily large, as it's moving towards infinity. What will be the behavior? And whatever the behavior it is, will make us to conclude whether it converges or it diverges. Similar thing will happen with the series. We want to consider the infinite case and be able to draw the conclusion whether the series will converge or it will diverge. For this course, you must know that if I do not put any counter, I just leave it here, this implies infinite. I mean infinite series. Except otherwise stated, the counter starts from 1 and it ends at infinity. Please take note of that. The counter starts from 1 and it ends at infinity. Let's take some definitions that are required. We'll talk more about the summation sign later in this course. Now, definition. Before I take this definition, the definition I want to look at is partial sum. Partial sum. What does it mean by partial sum? We take it one after the other, then we'll be able to look at it. Suppose I have, let me say that Sn represent partial sum of a series. Don't write anything yet. A1 plus A2 plus A3 plus A4 plus AN plus it continues. What we mean is S1 is A1, S2 is A1 plus A2, S3 is A1 plus A2 plus A3, S4 is A1 plus A2 plus A3 plus A4. It continues, then Sn is going to be A1 plus A2 plus A3 plus AN. Now, let us interpret what we have on the board. My S1 is the sum of the first term. S2, sum of the first two terms. That's why you have it A1 plus A2. S3, that's the sum of the first three terms. A1 plus A2 plus A3. If I have S30, that is the sum of the first 30 terms. A1 plus A2 up to A30. So now the generalization now is Sn equals A1 plus A2 plus A3 up to AN. So this is what we call partial sum. But the generalization of partial sum is the last point that you have here, which is Sn. So let me now define partial sum. Partial sum definition. given the series summation I from 1 to infinity, which is A1 plus A2 plus A3 plus up to AN. Suppose Sn denotes the partial sum, comma, Sn is defined as Sn equals summation I from 1 to n, which equals to A1 plus A2 plus AN. That is the summation. Full stop. So remark. So let me now take this one as a remark. Remark here, let's take this one. Let's take it from here. Now the remark that S1 is sum of first term. Of course, it will remain first term. This is the sum of the first two terms, and it continues like that. So the question may ask you to find the sum of the first 4 terms. That is remark number 1. Can I proceed, or you are still writing?
Sir, yes, you can proceed, sir.
I can proceed. Okay.
Yes, sir.
Thank you.
We're writing now. Sir. Thank you, sir. So much.
Okay, hold on. I'll give you 2 minutes. I'll give you 2 minutes to do that. Can I proceed now?
Yes, sir.
Okay, let's proceed. Now, having said this, let me wrap up everything on the board. Now, since in most cases, we can't tell I from 1 to infinity where this one approaches. So what we normally do to get the sum is to now use our partial sum, the sequence of partial sum. That's what you're going to use. you take the limit as this partial sum, the limit of the sequence of partial sum as n approaches infinity. So that now takes us back to our sequence. So if the limit of this one exists, then we say that it converges. Otherwise, it diverges. So let me make it remark number 2. Remark number 2. If the sequence of Sn, which is partial sum, converges and limits, of course, this may become tautology, limits Sn, n approaches exists, then summation ai, I from 1 to infinity converges. So you take note of this, very, very important. Converges. Number 3. Let S denote the convergence series. Then S is called the sum of the series. That is, S equals summation ai, I from 1 to infinity, which is as a1 plus a2 plus a3 up to an plus it continues. So that is the sum. That is the sum of that series. Number 4. If limit Sn as n approaches infinity does not exist, then the series summation ai, I from 1 to infinity diverges. Take note of all these points. We're going to work with them as we move on. Okay, let me move on. Let me move on. So having said this, okay, this is where I need to move on. Let me take 1 to 3 examples before I move to another part of the example. Find the first 5 partial sums of the following series. A, summation 10 divided by 3 is for n. B, summation n divided by n plus 1. C, summation let me say lane n divided by n plus 1. Let me take it that way. Let's just look at these three. Solution. A summation. 10 is divided by 3 is for n from 1 to infinity. We are looking for the first 5. I only take 1 or 2 of them. So S1 will become 10 divided by 3. S2, 10 divided by 3, 10 divided by 3 squared, which is 10 divided by 3, 10 divided by 9. S3, 10 divided by 3, 10 divided by 3 squared, 10 divided by 3 cube. S4. So you find the value, substitute the value here, substitute the value here. 10 divided by 3, 10 divided by 3 squared, 10 divided by 3 is power 3, 10 divided by 3 is power 4, and so on and so forth like that. Let me pick C. I will leave B as a exercise. C. My S1 is ln 1 over 2. My S2 is ln 1 over 2 plus ln 2 over 3, which equals to ln 1 over 3. How do I obtain ln 1 over 3, please? Awada, your hand is up. Awada, please, kindly unmute yourself.
Hello, sir. That see, I did not see it clearly, sir.
The question or what I just...
No, the solutions, I did not see it clearly.
The solution, okay? Let me write it here. See, we are given summation ln n divided by n plus 1. We are saying that S1 is ln, substitute 1 here, 1 over 2. S2, ln 1 over 2 plus ln, substitute 2 here, 2 over 3. And I conclude that this is the same thing as ln 1 over 2. Sorry, 1 over 3. Ln 1 over 3. So how did I obtain ln 1 over 3, please?
Through the LCM, that will be 3 over 6.
Through the LCM, how do you mean? Madam, please, how do you mean?
Oh, sorry, I'm wrong, sir. Let me look at it again.
Look at it again.
Doctor, please, I have a question.
Ask your question, please.
Yes, sir. The first one you solved, that's the A. I thought we were supposed to find the first 5, right? I think we only did 4 out of the 5.
What?
I said that means we have only done 4 out of the 5. Am I correct?
Yes, you have to.
So we're supposed to do S5 also.
Yes, S5. S5.
Okay.
Student to verify, complete that.
Okay. So, and after doing that, we are supposed we can actually get a value for each of the
yes, you can get value for each of them. Yes.
Okay, sir. Thank you.
You're welcome. How did I obtain ln 1 over 3 here? Wilson.
Doctor, is it LCM 1 over 2 plus 2 over 3?
Damiloto, I will subtract 2 marks from you.
Doctor, sorry, sir, I was kind of confused.
No, don't be confused. Look at it very well. Wilson and Okpele Yeru over the two of you. What have I done here to get ln 1 over 3? Okpele Yeru and Wilson. Kindly unmute yourselves. Damilotu, you are raising a no. Let me allow Okpalo Yeru and Lucy. Okay, Dami, go ahead, please.
Okay, doctor.
Yes.
So the second one, since we are on S2, so we are on the first one will be 1/2. Then when the value of n is 2.
Okay, Agumbi Ade Rashid, go ahead, please.
I think you subtracted 1 from the second variable minus the first one.
That is not true. Rashid, I disagree with you. Okay, I will help you. The fastest mouth and the fastest finger may likely have 2 marks today. Use law of logarithm. Because you're dealing with log. Use law of logarithm. How did I obtain it?
Okay, that's 2/6. So that's 1/3. We multiply the 2 fractions. That's why the fastest mouth to 2 marks for me.
The fastest mouth. Okay. 2 marks to Damilotu and 2 marks to Peace.
Thank you, sir.
So you are working on the logarithm. Addition here we change to multiplication. Then we have mean 1/2 times 2/3. So I have told you when you are working in mathematics, do not restrict yourself to the topic of the discourse. Anything can come in. You may need the knowledge you acquire in primary 1 to solve an advanced mathematics. The moment you pretend that you are an advanced person and you cannot think back to your primary school, you may not likely solve the problem. Of course, this is a secondary school work. Logarithm. And if you are not looking at it as logarithm, then there's no way you'll be able to solve that. Following the same pattern, I have my S3, ln 1/2, plus ln 2/3, plus ln 3/4, ln 1/4. So technically, my S4 is ln 1/5, and my S6 is ln S5 is ln 1/6. And that is the partial sum. Now, having said that, what is now the significance of the partial sum to our discussion? Fidelis, go ahead, please.
Doctor, I want to ask, because this lane normally confuses me. On what base is that lane? Is it base 10 or I don't know the base? Sir.
The lane?
That lane.
Okay.
Yes, sir.
Recall that log to any other base, to any base here, other than 0 and negative is common logarithm. Common logarithm. How do I mean? Log base 2 is common. Log something base half is common. Log 8 is common. But the moment you have log to base e, this is otherwise known as lane. And it is called Napierian or natural logarithm. Take note of that. It's called Napierian or natural logarithm. So, having said all this, the significance of partial sum. So, partial sum and convergence series. You should know that partial sum can be used to determine whether some class of series converge or not. Some class of series, not all the series, but some class of series, we can actually determine whether they converge or not. How do we do that? Partial sum can be used to determine if some classes of series converge or not. To do this, the idea of partial fraction and two, telescoping series are required. Full stop. So what do we do? I will take examples. I will combine the two of them together, and we go back to some of the remark I gave earlier on, so that I'll be able to see exactly what is going on here. Let me start this way. Examples. Discuss the convergence of the following series. A, summation 1 divided by n into n plus 1. B, summation 1 divided by 4n squared minus 1. C, summation n from 4 to infinity. N from 4 to infinity of 3 divided by n into n minus 1. D, summation. Let me take some question here from the textbook. I have, I have 1 divided by n into n plus 1 and n plus 2. Let's look at these 4 questions, then we discuss. Copy what you have down on the board. Madam, please, your hand is up. Kindly unmute yourself.
Doctor, please, I can't see number 4 example. It's not clear.
Number 4 example. Okay. Let me write it at this part of board. Summation 1 divided by n, n plus 1, and n plus 2.
Okay, thank you, sir.
So that's what we have. Now let's now look at how do we solve each of these. Now A, summation 1 divided by n, n plus 1. So the first step is resolve. Resolve 1 divided by n into n plus 1 into partial fraction. Partial fraction. I want to resolve this. Of course, 1 divided by n to n plus 1 equals 1 over n minus 1 over n minus plus 1. I have resolved into partial fraction. Any question on the resolution? Any question on how we resolve that?
Doctor, how did you do that? Yes.
How did I do that? Fidelis, please unmute yourself.
I wanted to ask the same question, sir.
The same question. Okay.
Why is it not mine? Why is it minus, not plus?
Why is it minus? Why not plus? Okay. I taught you this in one of our previous classes while you were in year 2. Maybe you have forgotten. To resolve this, let me take as many as possible. Suppose I have 1 divided by x plus 1 and x minus, let me use x minus 2 and x plus 1. For instance, I told you then, you pick this. What value of x will make this one to become 0? Yes. What value of x will make this one to become 0?
2.
2. Now, you substitute 2 here. 2 plus 1.
3.
Is there any x at the numerator?
No, sir.
No. So that means that we have this one to be 1 divided by x minus 2. What value of x will make this one 0?
Minus 1.
Put minus 1 here. What do you have?
Minus 3.
Minus 3. That becomes minus 1 over 3. Minus 1 over 3 x plus 1. Then we have resolved. Suppose I have it as x plus 2, for instance, divided by x plus 3 into x plus 5, for instance. I want to resolve. What value of x make this one 0?
Minus 3.
Minus 3. Put minus 3 here. What do you have?
2.
2.
Plus 2.
Put minus 3 here. What do you have?
Minus 1.
Minus 1.
So that becomes minus 1 over 2 divided by
Minus 1 over 2.
x plus 3.
X plus
What value of x make this one 0?
minus 5.
Minus 5. Put minus 5 there.
Minus 2.
Minus 2.
Minus 2. Put minus 5 here. What do you have?
Minus 3.
Minus 3. The negative cancel each other. Then we have plus 3 over 2 x plus 5. We did all this in one of our previous classes last year. So the same thing I did here. So what I did here, the value of n that will make this one 0 is 0. Substitute 0 here. This will give us 1. 1 divided by 1 is 1. So that's the one you have here divided by n. The value of n that make this one 0 is minus 1. Substitute minus 1 here. You have 1 divided by minus 1. You have this. So after this, we will now go to telescoping series. How do I mean? This now implies that I have summation 1 divided by n into n plus 1 equals summation 1 divided by n minus 1 divided by n plus 1. N from 1 to infinity. I believe you have all written. You have all written the question. So I can rub off the question. I can rub off the question. Now, what you are going to do under telescoping is to substitute for every term of this series into this resolution of partial fraction. However, you must not simplify. You can arrange it horizontally, but I always advise my students, arrange your telescoping vertically so that you can easily see what is going on. What do I mean? Is equal to now. Substitute 1. I have 1 minus 1 over 2 plus, because the summation sign simply means plus. So let me calculate Sn. My Sn now equals, substitute 2. We have 1 over 2 minus 1 over 3. Substitute 3. 1 over 3 minus 1 over 4. Substitute 4. 1 over 4 minus 1 over 5. Now, let us observe. Did you observe anything from what you have on the board? Yes, if you have observed anything, let me know.
Yes, sir. I
Yes.
observed something.
Yes, yes, sir.
Okay, Fidelis, what did you observe?
I observed that the next term is the last term of the other series. Like 1 over 2 minus 1 over 3 begins the next term. 1 over 4 begins
Yes,
the
that's
next
one
term.
observation. Any other observation? I agree.
Yes, sir.
Yes, Balogun.
Sir, the first part of each term, the first part of the next term is lower than the first part of the previous term.
Yes, I agree. Okay, let me help all of you. Let me help all of you. And that will be, okay, Dami Lotun, go ahead, please. Dami?
Okay. Yes, doctor.
Yes.
So the last term that we are subtracting is approaching infinity.
No. Let me help you so that you'll be able to see. Fidelis actually got something right. 1 mark for Fidelis, and then 1 mark will be the fastest match.
Thank
1
you.
mark
Thank
for
you,
Fidelis.
doctor.
Yeah, you're welcome.
Thank you, sir.
You're welcome. The fastest match now. Dami, mute yourself. Dami Lotu, don't say anything. Okay, you still want to talk? Oh, yeah, talk. Dami Lotu, go ahead, please. Dami Lotu, your hand is up. Please go ahead.
Okay, doctor, can you hear me?
Yeah, very well.
Yes, okay. I see that as we move, I think we are still approaching the partial.
No, just
fraction.
hold on. You will see it now. Now, look at the diagonal of what you have. Did you observe anything diagonally?
Yes, they cancel out each other.
They cancel out each other. Can they thank you?
Yes.
Can they thank you? They cancel this out order. So can they 1 mark, please? Diagonally, you see that this cancel this, this cancel this, this cancel this. It continues that way, diagonally. If that is the case, I will now ask myself, how many terms or terms does or do not cancel from beginning? How many of them do not or does not cancel from beginning?
Only one.
Only one time. Only one time didn't cancel from beginning.
That is the first one and probably the last time too.
Now, the number of times that do not cancel from beginning will be the number of times that will not cancel at the end. That is what you must know now. The number of times that do not cancel from beginning will be the number of times that will not cancel from the end. But they must be in the opposite end. That's number one. The number two, I will now continue. Since only one time do not cancel from beginning, I will evaluate the does not cancel from beginning, rather. Only one time does not cancel from beginning. I will evaluate the last 2 terms because what I want to calculate is partial sum, Sn. I will evaluate the last 2 terms. And from our sequence, we have 1, 2, 3, 4. The last term is n. The term just before n is n minus 1. I will substitute n minus 1 here. I will have 1 over n minus 1 minus 1 over n. Substitute n in this expression, we have 1 over n minus 1 over n plus 1. Observe, this cancel out. So that means that a term will have cancelled out this, another term will have cancelled out this. What are we now left with? We are now left with Sn equals 1 minus 1 over
1 minus
n plus 1. That's our Sn. So The question only asks us to discuss the convergence. However, I will answer some questions now from here before going to the convergence. The question may be, what is the partial sum? What is the what? Partial sum. In that regard, I will need to simplify this. My partial sum is Sn, n plus 1 minus 1 divided by n plus 1, which equals n divided by n plus 1. That is my partial sum. Did you see that? I computed it. That is, I have answered one question. I have not discussed the convergence, but that's what we obtain for partial sum. Now stop writing. Let's take our mind back to real analysis 1, when we are looking at mathematical induction. There was one mathematical induction question, 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus 1 divided by n into n plus 1. And we say that answer is n divided by. Do you remember this question?
Sir, we remember, sir.
Do you remember this question?
Yes, sir.
Yes. This is how we obtain the sum of the first n terms, because your partial sum is the sum of the first n term. That if you sum all this one together, the answer will be n divided by n plus 1. This is how we obtain that result. Every other question under mathematical induction that we did last year, we can generate our sum. It depends on the type of question we are given. Maybe one of our free period, I will look at that. Some of the questions we did under the mathematical induction. How do we generate the sum to each one of them? We are going to look at all that during our free period. But as of now, this is one of the problems we solved then, and this is how we generate the sum of the first n term, which is now our partial sum. Now, the convergence now. Let me now go to the convergence. Go back to our remark. I think remark 2 or remark 3. What does it state? Go to remark.
Okay, remark 2 says, if the sequence of partial sum converges.
Yes.
Can I continue, sir? Is that one?
Continue.
Okay, if the sequence of partial sum converges and the limit of the partial sum as n approaches infinity exists, then the summation of I starting from 1 converges.
Thank you very much. Now, so from what you have read now, what should be our approach from here? What should be our approach from here? To discuss the convergence. So the approach now is, we'll now take limit of the partial sum n towards infinity, which is limit. You can take this, you can take this, but I always advise my students to take this one. That one is easier as n approaches infinity. As n approaches infinity, 1 with 1 divided by n plus 1 becomes. What will this one become? Yes?
0.5.
Zero. Thank you. This approaches 0. As n approaches infinity, the whole of this expression here becomes 0. And do not forget, limit of any constant is what? Limit of any constant. You need to go back and review your reanalysis 1. Limit of any constant is constant. So this becomes 1 minus 0, which is constant. Therefore, summation 1 divided by n plus 1 what converges. It converges because the limit exists. Now, further,